Hello, everyone. Welcome to today's session, live coding session brought to you by Hamoye. And as always, my name is Ajulo Christian, and I'll be your host for today. All right. What we have in store today will be like a continuation from last session. We're still dealing on machine learning regression. But today we'll be working with different data sets. So thank you for joining those on YouTube and on Zoom. So without wasting any time, let me just start sharing my screen and then we begin. All right. Okay. I guess everyone can see my screen now and can hear me clearly. Just confirm by dropping it in the chat box. So I move on. Okay, cool. So today we'll be working with the data set called the medical costs personal data set. What we'll be doing will be a medical insurance prediction / or forecast. So it's also a regression problem. And this data set is available on Cargo. You can get it from Cargo. Let me just give a brief overview of what we have in store. So insurance, like we know, insurance companies need to set the insurance premiums. If you remember from the last session, I said machine learning regression can be applied in several sectors, medical, finance, and all. So today we'll be working with a use case like in insurance. So insurance companies need to set the insurance premiums following the population trend, despite having limited information about the insured population. So that's if they have to put themselves in a position to make profits. So this makes it necessary to estimate the average medical care expenses based on trends in the population segment, such as smokers or drivers. That's based on this particular data set I'm working with. So, like I said, data sets available on Cargo. It's called the medical cost personal data set. So the aim here would be to predict the medical costs billed by the health insurance on an individual, given some or all of the independent variables of the data sets. So since the cost is to be predicted, it's a continuous variable. So it is natural that this will be a regression problem. So that is without the decision boundary as in regression-based classification. Well, this is just English. We get to the code, you understand better. So we could implement polynomial regression, multiple regression, or even elastic net regression. But what we'll be working on today will be some different regression algorithms. The last time we worked with just random forest and decision tree. So today we'll be working with several other regression algorithms. So as always, I already have the code set up, so I'll just explain as we move on. First of all, load data. If you were in the previous session, I already gave a brief steps on steps to follow when you're working with machine learning regression problems. So I'll be talking about that again. So I'll just be moving on with the code. So loading my data, I already have my data available. Viewing the data. So this is what we have in the data set. It contains different columns: age, sex, the body mass index, children, if the person is a smoker, the region or not, the region, and the charges. Our target column will be the charges. That's what we're trying to predict. Let me scroll up, you understand. We're trying to predict the medical cost billed by health insurance on an individual given some or all of the independent variables. So we're predicting the charges using these variables. So moving on, checking the info of our data. You can see the data type has numerical and of course categorical variables in our data. So to check if we have missing data, And this data set is pretty much clean. There's no missing data. So we don't have to handle the missing data. So doing further analysis on our data to try and understand what we're working with. And this describe, mind you, this code only works with the numerical data. That's what this describe does. It will show you different analysis of your data sets of the numerical columns. It will give you analysis of the categorical columns. So to do a brief data analysis on my data to try and understand what I'm working with, I'm going to get the average body mass index of the individuals in the data set. So that's what this code is doing here, this particular code. Just by checking the mean, that's the average. So of each person. So in our data set, we have the average body mass index is 30.6%. So probably as you're working with data in a company and they told you to ask for this data set we have, what's the average body mass index of each individual that's relating to this data set, which from different geological locations. So the average BMI is 30. Then also in our data sets, we have the children column. That's if the particular clients, how many children do they have? Some of them have 1, 3, or 0. So these are like the customers of the company, that's the insurance company in their database. So let's check the percentage of individuals who have children to see how it will affect the decision of the company on how they will bill the individuals. That's the cost that will be then a medical cost, because it's a medical cost insurance. So percentage of people that have children is 57%. So in this particular data set, we have 57% of individuals that have children, excuse me. So also to check the average insurance charges for individuals who smoke and those who does not smoke relating to the data set. So there's a column that if the individual is a smoker or not, yes or no. Mind you, it's a medical cost insurance. So to check the average amount they will bill an individual that smoke or does not smoke, let's just run this analysis. What this code is doing is checking for the data set. If the smoker, yes, and the charges column, look for the average, and also the data sets in the column for smoker that is no, look for the average, that's the mean, the average. Then this code will just print out the answers. So in this analysis from our data set, found out that average charges for smokers is $32,000. Then average charges for non-smokers is $8,000. So this means that the company will charge more for those that are smokers than those that are non-smokers. So then moving on, let's just wait for this to load. Okay, checking our data set again to do more analysis. If you notice, we have categorical and of course numerical column. Like from the last session, you have to handle, process your data and encode it to all needs to be numerical column. So with this, if you remember the last time I used one-hot encoding and I explained about label encoding and one-hot encoding. So this particular time, I'm going to try to understand our data set to see if we're going to use label encoding or one-hot encoding. So let me just check the unique variables in this region column. So we have southwest, southeast, northwest, and northeast. So, and also checking the unique variables in the sex column and smoker column. So these are the categorical column. So we have male and female, and in smoker column we have yes and no. So with this, you know that we have to use label encoding because this has a particular way of ranking. Unlike one-hot encoding, you can apply that when there's no ranking. So with this, we have male and female. You can use label encoding. When it's female, it might be 0. When it's male, it's 1. So going down to the processing, I'm going to use a for loop to give me my categorical columns. That's what the code here is doing. I'm too fast as I'm going on, just dropping your questions in the chat, and I'll be happy to give you an answer when I'm done. So, creating my numerical columns, we have the age, the BMI, children, and charges. So these are the numerical columns, and for the categorical columns are columns that are non-numerical. That explains itself: text, the smoker, and the region. Then I want to encode it using label encoder. So I'm encoding the categorical columns. So I'll import my label encoder. I would give it a variable called LE and pass a for loop. See, for I in categorical column, that's for index in categorical column, my data frame of I will to fit transform my data frame that has a categorical column and encode it to numbers, to numerical data. So let me just run this code. Then we'll check our data. You see that now it has encoded the data into numbers, numerical data. So like I said, this text that was female represented it as 0, then male 1. Then for smoker, yes, it's 1, smoker, no, 0. For the different region, it presented not, I think this is northeast as 3 and all that. So label encoder is the best encoding method to use for this particular data. So let's just run this code again to see, okay, if you notice the text, female was 0, male 1, smoker, yes, no, 1, 0. Then for here in the region column, if I go back and see, okay, so with southwest, southeast, northwest, northeast. So it's presented it as 3, 2, 1, 0. Okay, so moving on to the modeling proper, let me do a heat map to understand in my data, which is more correlated and which would affect the algorithm more. So I'm going to sum up a heat map. This using Seaborn. Those in data storytelling track should know Seaborn. Even those in data science should understand Seaborn and Matplotlib. So I'm going to draw a heat map to understand my data. So this heat map, what is doing here, this side is too big. Let me reduce it. 11. Okay, it should be better. Okay, let's make this 5. So what this is showing here is showing the columns that are correlated. So if you notice here, this smoker region is more correlated than the age column. So this is what this heat map makes you to understand your data, which of the data is more correlated and least correlated. So moving on, I'm not going to dwell on that. Like I said before in the last session, we used just 2 algorithms. So for this session, I'll be applying several other regression algorithms. So let me just install my CatBoost regressor by running pip install. So I already have that installed. So all right. Then the algorithm I'll be using random forest regressor, the CatBoost regressor, the gradient boosting regressor, the HGBoost regressor, decision tree, K-neighbors, ridge, SVRO, and linear. All these regressor algorithm are there in your scikit-learn library. So I won't be giving the explanation of all. You can go to the scikit-learn documentation to understand what each of them will be doing. And you might be asking why I'm using a lot of regression algorithm. There's a method I like applying. I like applying 4 to 5 algorithm, and I'll see which one works best. Then I will now what we call tune it, fine-tune it as tune hyperparameter tuning for a particular algorithm that works best for me. But for this session, like I said, we won't be covering hyperparameter tuning and deployment. That will be for the next stage, stage 3. So those in data science track, you get to see that. For those in data engineering track, you get to be working with Kubernetes, production to Kubernetes. So we won't be doing this. So moving on, let me just import and run this code to import this algorithm and also importing train test split, my evaluation metric, the mean absolute error, the mean squared error, and my R2 score. So let's run that. Then splitting my data into X and Y. Our target variable is the charges column, which is this guy. Yeah, this column. Then dropping this column for the X, then the Y will be just this column. So loading that, splitting it into train and test. I'll be using a 20% test size. Okay, somebody's asking me a question. Cat boost. Normally in your Jupyter Notebook or Google Colab, there are some pre-installed algorithm. So you might not have it, you have to install it in your notebook or in your local machine. So that's what I did. I just installed Cat boost regressor algorithm. So that's what that code is doing. I had to install it. I had others because if you run it, probably I didn't have it. If I run this code from CatBoost, import CatBoost regressor, it throw error. So I have to install it. Pip install CatBoost. So that person asking that question. So moving on, checking the shape. Then creating a dictionary like I always like doing. Instead of running the codes one by one, that's redundant. So I'm putting all my algorithm in a dictionary, importing them. I'm creating a function called fit and score. It will pass in the model, the training data, S-string, S-test, Y-string, Y-test. It will create a random seed of 42. I explained the meaning of random seeds in the previous class. Then to discuss, they will put them in a dictionary. That's what this code is doing. Then it will create a for loop that will loop through each of this algorithm and fit them and provide the scores. It will return the model score. That's what this particular code is doing. So instead of running your code one by one, just put it in a dictionary to avoid redundancy. All right, so have I run that code? Let me see. Okay, no, I have running that code. Mind you, it's fast because I'm on Google Colab. I'm not on my local machine. So for you, it might be slow, depending on your machine RAM space too. So let's call this. You might be wondering what this is doing. This particular one, that was fast. That was very fast. 2 seconds. Interesting. So what this is doing, this is the learning rate. This is produced from my cat boost. Let me see. Rate. I can put it in my code to remove the outputs. That's what this code is doing here. This output you're seeing is showing you the learning rate of how your regressor CatBoost algorithm is performing, fitting and scoring. So I'm not doing on that. Scroll down. So the results we have for the different algorithm, we see the SG boost was 0.85. That's the default scoring method for a regression algorithm is the R2 score. That's the coefficient of determination. So for my SG boost regressor, it was 0.85. For decision tree, didn't do well, 0.6. Random forest was good, 0.86. Cat boost did well, 0.868. Okay. Gradient boosting, I think gradient boosting performed better, 0.87. K neighbors didn't do well. Ridge, SVR was pathetic. Linear regression, 0.78. So to put them in a visual, I like doing that so you see how they perform. So with this, the best model here was the gradient boosting regressor. The gradient boosting regressor algorithm. So that was the best model, 0.87. So I'm going to select that and work with that graded boosting regressor model. So I'm just going to call it again and fit it. What this code was doing for me is it just performed that's my modeling for me faster to see which one was best instead of me running it individually. So that's I selected my graded boosting. So I'm just going to run that again, select it, and score it, give the score. So I had my 0.87. I'm making predictions with the graded boosting regressor. So these are the predictions, and these predictions, mind you, are the medical cost, that's the charges. So what you're seeing here are the charges my model predicted. So let me just view the first 10 predictions. So these are the first 10 predictions using slicing from the beginning to the 10th one. So these are in dollars, mind you, from our data set. So now the next step is to evaluate your data, like we discussed in the previous class. I'm not going to dwell on this. We have the mean absolute error, the mean squared error, and the R squared, which is the coefficient of determination. So running that code, my mean squared error, passing my y test and my y spread, the root squared error, 4,000, then the mean absolute error. So for this, we had that for the base model, we had the mean absolute error of 2447. What this means, like I already explained, is that our model achieves a mean absolute error of 2447.16, which means on average, our model predictions are 2,447 units away from the actual value. So mind you, our predictions were predicting medical costs. So let me just put them in a data frame so you understand better. You might have seen this code before. So what this means, I'm putting the actual values in our data and the predictions. So when I said the mean absolute error evaluated our data that we had a 2447, means with each prediction, it is 2,447, let's say, dollars away from the actual value. So for this, the actual values was 9,000. It's predicted 11,000, which is not bad. Like this, 52, sorry, 5,000, also predicted 5,000. So 29,000 predicted 28,000. So this base model is actually okay. So you can also do what we call hyperparameter tuning, but we won't cover it for this stage. It will be covered in the next stage. And that next stage will be dealing on classification, algorithm, machine learning classification. So with that, let me draw a scatter plot to show how our model was behaving. So these are the blue is the actual values, the red is the predicted values. So that's that. There's something called the feature importance. To know which feature was more important that affected the models and predictions. So these are just numbers. Let me put it in a visual so you understand better. So what this code is doing, I'm going to create a function that will plot a bar plot to show my feature importance of my model. So passing the features and the features column. Okay. Let's run this code. Then plot it. So for our data, let me reduce the size too big. Size. Let's make it 8 and 6. Well, let's run this code again. Okay, so for our data, the column that was more important in making predictions was the smoker column. You understand? And when we did the analysis before, you see that the company might bill the individual that is a smoker more than a non-smoker. So this feature had more importance in the model's prediction. The next one was the body to mass index, then the age of the individual, then the children, the region, and the sex. So the most important features were the smoker column, the body mass index, and the age. So with that, we've come to the end of this machine learning run through. So if you might ask, as in the insights you got from this, your predictive analysis and your forecast, you say the features from your data set that was more important in predicting how much the company will bill the individual from your analysis, that the smoker column, that if the individual is a smoker, pertaining to this data set, they will charge more. If the person is a non-smoker, it will charge less. Then the body to mass index is also important. Then the age of the individual also is also important. So these are just the few run through of your analysis and your machine learning regression algorithm to understand how you perform your analysis. So we just did a few brief run through. So if I might be fast, it's because we've covered some of these things in the previous class. So this second session was just to make you get a better understanding of what we did previously. And for those asking about the previous session, it's always available on our YouTube channel. Go on our YouTube channel on Harmony HQ, you see that. And also on Slack, since you can't just find it on Slack, the YouTube link that was already dropped on Slack, just click on the link, it will take you directly to the session. So it's always available on our YouTube channel. So with that, we've come to the end of this session. I'm just doing a brief run through what we did from the beginning to the ending. So we load our data, did some analysis, there was no missing data. So I didn't have to handle any form of missing data. So I did a few analyses. The average BMI was 30. The percentage of individuals who had children was 57. Then the average charges for smokers was averagely high than those for non-smokers. That was why our model predicted that the smoker column had more importance to how the model was predicting the charges. So this is just a brief run through of everything. I guess everybody had a good understanding now. I'll just stop sharing my screen, then wait for like 5 minutes for questions. We'll have 5 minutes of questions. So if you have any question, drop it in the chat box. So, okay, let me go to the questions we have already. Okay, I already explained this, what the cardbook installation is meant for. There are some libraries you won't have pre-installed. You have to install it. That's what I did, pip install cardboost. Someone is asking, you did not get the link, like I said. Okay, the link for the previous session is available on YouTube. Just go to our YouTube channel, you'll see there. Then Chamaka is asking, can we also have access to the codes? The data set might be shared, but the notebook, I don't think to be shared. No, you can always go back to this video and practice along. And also this data set is available on Cargo. You can download it from there. It's the medical cost personal data set. You see the very popular data set. Okay, any other question? Okay, any other question? I have time for 1 or 2 questions, so we'll move on. Okay, someone is asking another question, how you can access the data. The data set would be shared on Slack, but it's also available on Cargo. You can download it on Cargo. It's the medical cost personal data set. It's a very popular data set on Cargo. You can get it from there. Any other question for quality day? Someone's asking, please, how can I install the cardboard if I want to? I just did it in the code. If you're following along, you would see it there. Just do pip install cardboard. It's simple. On your command prompt or on your notebook, pip install, just the way you pip install. I don't know if you're conversant with Python. By now, you should be conversant with Python, how to install Python modules or libraries. If you still don't know, Google is your friend. You can just Google how to do this. Simple pip install cardboard. I did it just now. If you're following along in the code, you'll see the pip install cardboard. Any library you want to install, you can just check the documentation on how to install it using pip install. If it's on your command prompt, use pip install. If it's on your notebook, put exclamation mark, then pip install. That's how you do it. Then how can you get to YouTube channel? Just go on YouTube and search for Hammer HQ. You see it there. Then if you can't start searching, if you are on Slack, the Zoom link and the YouTube link is always shared on Slack by the coordinator. Just click on the link on the Slack track channel. It will take you directly to the video. Simple. That's it. So the absence of no further question, I guess this is where we'll call it today. Thank you very much for joining. And this stage is almost coming to an end. As you are doing your premium projects, always remember that you are also in this stage V. So do well to complete the quiz and your tag along projects for those that are doing tag along projects before the deadline. And like it was already announced, there will be a break from stage B before stage C, so you concentrate on your premier project. The premier project is very important that you participate actively. If you don't participate actively on it, you will not be moving on to stage D, not stage C. So you will not be moving on to stage D. So it's important that you participate actively in the premier project. In the webinar session that is to hold tomorrow, you should have got your mail by now. So these are the compulsory things you need to do. So thank you everyone for joining. As usual, my name is Julo Christian. I'm a data scientist at Hamway and also the Assistant Programs Manager. Thank you very much for joining. See you next time. Have a lovely weekend.